this lesson. Once again, I'm teacher Katimbo Richard, teaching mathematics. In the previous lesson, we looked at integers, specifically how to add. We said integers using a number line and without using the same number line, as well as subtracting them using a number line or without use of that number line. Today we are continuing with the same integers, this time round multiplying the same integers. So the subtopic is multiplication of integers. In this class P7, which will be found on page 9 of your workbook, the first term, which you ought to have got from school. If not, then hurriedly go to school and get that copy so that you follow very well. So the examples are here. And the first one says, work out positive 2 times positive 3 using a number line. Work out positive 2 times positive 3 using a number line. So when you are given a number like this, you start with the meaning. You say, since this is positive 2, then it qualifies to be called a 2. And positive 3 qualifies to be known as a 3. For any integer without a sign is a positive integer. So positive 2 times positive 3 is the same as saying 2 times 3. So 2 times 3 means 2 forward jumps of 3 each. 2 forward jumps of 3 each. Unlike addition and subtraction of integers, where you use straight arrows, in multiplication of integers, one uses jumps, and one must first interpret the meaning. Like I'm saying, 2 times 3 means 2 forward jumps of 3 each. So you are going to make jumps, and you're going to be 2 jumps of 3 each, meaning from the origin, that is 0, you count 3, 1, 2, 3, and jump from here up to here. Please jump towards the positives and show the jump being forward, meaning you are going in front to the front, and of 3 each. So I've counted 3, that is 1, 2, 3, jump from 0 up to 3, or positive 3, and show the arrow, that's a forward arrow, and so 3, that's the first one. So I'm remaining with only 1 jump, because there are going to be 2 jumps. So the next jump of 3 is counted from here, say 1, 2, 3, and jump from positive 3 to positive 6, and name it as 3. So it is a jump of 3. And now that's the last jump. So this is the first jump, the second jump of 3, and where the second jump of 3 stops is where the answer is. Identify it in this way, and then say therefore positive 2 times positive 3 equals positive 6. Please ensure you adhere to the meaning. There are 2 forward jumps of 3 each, so meaning you jump twice, and each jump must be of 3. Show the movement, that is the forward jump, and 3 each. So I've got to have that 3 twice, twice 3, that's 2 times 3, 3 twice, 3 2 times. So you jump that 3 twice, so that is 2 forward jumps of 3 each. And where you step at last is where the answer is. So the second jump of 3 stepped at positive 6, thereby concluding that positive 2 times positive 3, one attains positive 6. Then we shall look at the second example about multiplication of integers using a number line, which reads, work out 3 times negative 2 using a number line. Work out 3 times negative 2 using a number line. Like I said before, in multiplication, one first interprets the meaning, and therefore says 3 times negative 2 means 3 backward jumps of negative 2 each. 3 times negative 2 means 3 backward jumps of negative 2 each. Still draw that same number line, and this time you are going to jump backwards, and you're going to make 3 jumps backwards, but each baptized or named negative 2. So start from the place of origin, which is 0, and please jump. Please, each time you jump negative 2. So count, this is negative 1, negative 2. Jump from 0 up negative 2, and short is the backward movement or jump, and name it negative 2. And remember, there are going to be 3 jumps. The second jump starts from where you have stepped first, that is from negative 2, and count negative 1, negative 2. So that is a negative 2, and show the arrow of movement, and then count again, negative 1, negative 2, that's negative 2. So this is the first jump, the second jump, the third jump, and you say you are making 3 backward jumps of negative 2 each. So put negative 2 against any jump or each jump. That is negative 2, that's the first, negative 2, and negative 2. Where you stop or you step last is the final answer. Therefore, the final destination is negative 6. We say therefore 3 times negative 2 is equal to negative 6. There must be 3 times. Negative 2 appears thrice, that is once, twice, thrice. So thrice negative 2. These are 3 negative 2s, and stepping at negative 6. And that is the way one works out the multiplication that involves a negative but using a number line. In that way, you have answered that question, as opposed to example number 3 that tells you to work out negative 4 times negative 5, this time without using a number line. You are not going to use a number line this time because the examiner has dictated that without use of a number line, do multiply these 2 integers, each is a negative. So this is the way you work out. You say negative 4 times negative 5, as I've been asked, no number line to be used. So you are going to multiply the negatives first. That's a negative times a negative, you get a positive. Then the digits, that is 4 and 5. Last, that's 4 times 5 is 20. So I've got a positive outcome in terms of multiplication of a negative and another. Then a 4 by 5 as a 20. You say therefore negative 4 times negative 5 is equal to positive 20. In that way, you have answered. Please first multiply a negative by a negative. Like we said in the previous lesson, when one multiplies the same signs, one gets a positive, and when one multiplies different signs, one attains a negative. That is was done in the previous lesson. That's why now we are saying negative and negative is a positive, and 4 times 5 is a 20, thereby concluding that negative 4 times negative 5, one attains a positive 20. That is without use of a number line. Before we look at number 4, that tells us to work out negative 4 times positive 2 without using a number line. Without using a number line. Please work out negative 4 times positive 2 without using a number line. Like I've done before, that is number 3. We say negative 4 times positive 2. First multiply these signs. We say negative times the positive. Being that they are different, they produce a negative. Before you multiply 4 by 2 here to get 8, so that you get negative 8 as the outcome. And conclude, therefore, negative 4 times positive 2 is equal to negative 8. That is without using a number line. In short, 1 first multiplies the signs before 1 multiplies the digits. And then the outcome is then concluded here. So that's how we deal with integers in terms of multiplication using a number line and without using the same number line. And now we are going to look at application of integers in daily life. Application of integers in daily life. How applicable are integers at school and after school? One must look at the keywords before one starts applying the integers in daily life. The keywords to application of integers are: 1. Temperature rise. Wherever you see rise in temperature, you just know you are going to apply positive integers. Words like climbing, we apply positive integers. When you see movement forward, you apply positive integer. When you see AD, which means in the year of our Lord, still apply positive integers. Someone arriving late, that is positive integer application. Someone receiving anything like money, that is application of positive integers. Somebody arrives after the normal time, that's still application of positive integers. Somebody winning some points or winning a particular gift in terms of counting, you just know somebody is applying a positive integer. So whenever you see words like temperature rise, climbing, forward, AD, late, receive, after, and win, you apply positive integers. Then words like temperature fall, descend, backward, BC, before, date, or the word borrow, and loss, you apply negative integers. So we are going to use those words. Any of those words cited, know what integer they actually apply. The examples are here for us to apply positive or negative integers. And the first example today reads: Tom arrived at the station 15 minutes before the normal departure time for the bus to Nairobi. It reads again: Tom arrived at the station 15 minutes before the normal time departure time for the bus to Nairobi. If the bus was 35 minutes late, how long did he wait for the bus? It reads again: Tom arrived at the station 15 minutes before the normal departure time for the bus to Nairobi. If the bus was 35 minutes late, the main question says, how long did he wait for the bus? Now, you look at the keywords that will introduce us to the application of integers. The fact being that this Tom arrived 15 minutes late or 15 minutes before, you say 15 minutes before represents negative 15. And then the bus was 15 minutes late, you say it was 35 minutes late. You say 35 minutes late represents positive 35. And when the question asks for how long somebody waited, you just know they are actually asking for duration of waiting. So you say duration equals ending time of waiting minus starting time of waiting. In terms of integers, the ending time of waiting was positive 35, and the starting time of waiting is negative 15, because that's when he arrived there and waited for 15 minutes before the normal departure time, and then he left, or he ended waiting 35 minutes after the normal time of departure for that bus that heads to Nairobi. Therefore, we say duration equals positive 35 minus negative 15. Positive 35 minus negative 15. And then continue and say duration equals positive 35 minus negative 15. When you put this in brackets, I told you we shall, in the previous lesson, we shall never subtract two same signs or two different signs when they are together. We eliminate through multiplication so that it remains one. So we eliminate by multiplying. So we say negative and negative is a positive. We put these in brackets in order to eliminate the two signs through multiplication. You say negative and negative get a positive, thus getting duration equaling to 35 plus 15, which 35 plus 15 makes a 50. So duration is equal to 50. So the question being that, says how long, or for how long did he wait for the bus? You say therefore he waited for 15 minutes for this bus before he departed to Nairobi. In that way, you have answered that question. But in short, you must note the word before and late. So the fact being that this storm arrived 15 minutes before the departure time, that 15 minutes before means negative 15, and that the bus did not come on time. It arrived there 15 minutes late, 35 minutes late. So 35 minutes late means a positive 35. And you know duration is equal to ending time and starting time. So ending to wait was positive 35, and actually starting to wait was a negative 15. So that is how you apply the subtraction of integers to find the duration in minutes in that way. Before we look at number 2, that reads, Mukasa borrowed 50,000 shillings. Mukasa borrowed 15,000 shillings. He then received 72,000. He then received 72,000 shillings as salary. He then received 72,000 shillings as salary. The question says, what is his balance? What was his balance after paying? What was his balance after paying? The word is was here. What was his balance? What was his balance after paying the debt? Mukasa borrowed 50,000 shillings. He then received 72,000 as salary. The question is, what was his balance after paying the debt? Now, remember, we're applying integers, we don't just subtract. So when you see the word borrow, like I said, you apply negative integer, and that Mukasa borrowed 50,000 shillings, you say Mukasa's borrowing 50,000 shillings represents the application of negative 15,000. Whereas Mukasa's receiving of 72,000 shillings as his salary represents positive 72,000 as an integer. And now, what happened first? It was Mukasa's borrowing. So go in the order of the two kinds of things. So what happened? It was borrowing first before he received the salary. So you say negative 50,000 plus the positive 72,000 shillings as the events did happen. So then continue and say negative 50,000 plus positive 72,000. What do you then do? Because we have cited these two sides together. We eliminate through multiplying. So put this in brackets so that a positive and positive get a positive. So in the next step, I've got negative 50,000 plus 72,000. And as we said before, wherever a negative leads a positive or wherever a minus leads a plus, we interchange. So negative 50,000 plus 72,000 can be interchanged with 72,000 minus 50,000. Before you write this part of work to subtract accurately, that's 72,000 minus 50,000, thereby getting 0 minus 0 and 0. 0 minus 0, 0, 0 minus 0 is 0. 2 minus 0, you get a 2. And 7 minus 5, you get a 2. So thereby remaining with 22,000. So the question is, and was asking for the balance this Mukasa had after paying off the debt. So we say therefore the balance was 22,000 shillings after Mukasa settled that debt. In that way, you have applied what is called integers. Please look at the order of the events. It was Mukasa's borrowing first, so negative 50,000 first, before receiving the 72,000 shilling salary. So follow that one, although at last you will subtract in this form because of the order of these integers. That will have answered and following the application of these integers. Before we look at the last example that concludes this lesson today, which is the third example that reads, Jonathan won 57 points, then another 20 points. It reads, Jonathan won 57 points, then another 20 points. He later lost 31 points and another 50 points. The main question reads, what was his final score? What was his final score? Again, look at the key words that will actually take us to the application of the matter in question, that is integers today. I said when you see the word winning, you just know one applies positive integer. So the fact being that Jonathan won 57 points as well as 20 points, for these two, we apply positive integers. That's why in the solution you say winning 57 points represents positive 57, and winning 20 points represents positive 20. And then this same Jonathan later lost 31 points as well as 50 points. So that loss is interpreted to be application of negative integer. That's why you say losing 31 points represents negative 31, and losing 50 points represents application of negative 15. And now you are going to form the statement here of mathematics, but following the flow of the happening of the events. So positive 57 comes first, before positive 20, before you deal with these two negatives. So follow that order. Hence, right? Positive 57 plus positive 20 plus negative 31 plus negative 50 as the statement to be written in mathematics. And now I've got plus positive plus negative, which are this order, So we are going to eliminate through multiplying. Thus, put these added in brackets. That's why I say positive 57 plus into positive 20 plus into negative 31 plus into negative 50 before we multiply to eliminate, where we know that in positive times a positive, you get a positive. Thus, we've got 57 plus 20, and a positive times a negative, you get a negative. That is minus 31. Likewise, positive and negative, you get a negative 15. So the new statement is 57 plus 20 minus 31 minus 50. And now we first add before we subtract. Now 57 plus 20, you get 77. Now minus 31 minus 50. First subtract these two. 77 minus 31, 1 will get that 46 as shown in this side work. 77 minus 31, that is 7 minus 1, you get 6. And 7 minus 3, you get 4. Thereby getting 46 minus 50. And the fact being that 46 is far less than 50, we shall then first know 50 minus 46, which is a 4. Then the opposite of that 4 is a negative 4. So you get 46 minus 50 then is a negative 4. And say, therefore, his final score was negative 4 as the question reads, what was his final score? This Jonathan's first final score was a negative 4, meaning he got a negative kind of outcome because the loss was actually outweighing the gain. So he finally scored negative 4. In that way, you have applied what is called integers, both positive and negative integers. So in short, the study about how to multiply integers ends there today, and that's how we do apply the integers in our daily life at school and after school. I am teacher Katimbo Richard has taught you the integer multiplication and application today, and you have to answer work from page 9 all the way to page 12 of your workbook you have acquired for first term from school. In that way, you will be successful. For more information about the same, call Teacher Katimbo on 0776 251655. Otherwise, that's the end of the lesson today, and so stay safe.